Okay, so good morning, guys. So now we will do the 2019 paper question number 5, right? The question is based on pH titrations. Okay, so we'll start off with that. 2019 question number 5. Okay, right. What are they saying? A titration between the monoacidic weak base B and HCl was carried out using a suitable indicator, right? The HCl solution 25 centimeter cube was kept in the titration flask and the weak base was added using a burette, right? So what are they doing? They are keeping HCl in the titration flask, right? HCl is kept in the titration flask. The volume is given as 25 centimeter cube, and the concentration they have given as zero point 0.1 mole dm minus 3. Right? I'll write it as 1 into 10 to the power minus 1 mole dm minus 3. Right? And they're adding the weak base using the burette. Right? Using the burette, they're adding the weak base B. Right? And the concentration they have given as 0.15, so I'll write it as 1.5 into 10 to the power minus 1 mole dm minus 3, right? The HCl solution 25 kb they have given at 25 degrees celsius. Kb, the value of kb they have given, it is kb at 25 is 1 into 10 to the power minus 5. Kb at 25 degrees celsius is 1 into 10 to the power minus 5 mole dm minus 3, right? I hope y'all can see this. Yeah, it's visible, right? Okay. And they are saying all the experiments were conducted at 25 degrees celsius, right? They are saying all the experiments were conducted at 25 degrees celsius, right? Now why have they given this temperature? What is the reason for this? You all know, guys. Now if you take equilibrium constants, right? Kp, Kc, Ksp, Ka, Kb, anything if you take, all of them depends on temperature, right? So all of them depend on temperature. So here they have given the Kb value at 25 degrees celsius, right? And they are saying that the experiment was done at 25 degrees celsius, right? Which means the kb value does not change throughout the experiment, right? We have to take that kb value does not change throughout the experiment because the temperature is kept constant, right? If the temperature is changed, then kb value will be changed, right? But here they have kept 25 degrees celsius, so kb value is a constant at that temperature, right? Now what are they asking? Calculate the pH of the acid solution in the titration flask, right? They're asking the pH, initial pH they are asking inside this titration flask, right? How can we find it? Right, you all know that pH is equal to negative log 10 concentration of H3O plus aqueous, right? This is the equation to find the pH values, right? Now here, what is the concentration of HCl? Now HCl will be ionizing, right? HCl will be ionizing when put into the solution. It will be ionizing as H3O plus ions, right? It will be giving H3O plus ions and Cl minus ions. As this is a strong acid, it will be completely ionizing, right? So one HCl will provide one H3O plus ions, right? So we can say that the concentration of H3O plus, right? The concentration of H3O plus is equal to the concentration of HCl. What is the reason? One HCl will provide one H3O plus, right? So the concentration of HCl will be equal to the concentration of H3O plus, right? So then what is the concentration of H3O plus initially in the titration flask? The concentration of H3O plus will be equal to the concentration of HCl, that is 1 into 10 to the power minus 1 mole dm minus 3. Okay. Now what you have to do, you have to substitute this value in the pH equation, right? Then pH is equal to negative log 10 concentration of H3O plus is 1 into 10 to the power minus 1 mole dm minus 3, right? Then pH is equal to 1. Okay, right? Then initial pH in this solution is 1. pH initial is 1, right? Okay. Then they're asking the initial pH before the addition of weak base. What is the pH inside this solution? That is the question they have asked, right? So how can you find? You should know the concentration of H3O plus inside this titration flask, right? Then how can you find the concentration of H3O plus? The concentration of H3O plus is equal to the concentration of HCl, right? Because this is a strong acid and it completely ionizes and gives, right? So one HCl will be providing one H3O plus, right? Because the ratio is 1 is to 1. So the concentration of HCl will be same as the concentration of H3O plus provided by HCl, right? So the concentration of HCl is 1 into 10 to the power minus 1. Then pH we can find as 1. Okay, right. Now for the students who don't know to calculate the pH, right? This is a like the calculation is a little bit difficult, right? It's tricky, right? So how can you find? First of all, you have to write the concentration of H3O. Now here you have to put the concentration of H3O plus, right? You have to put the concentration of H3O plus. So when writing the concentration of HCO plus, first you have to write it in the scientific form, right? For example, let's assume that concentration of H3O plus is 1 into 10 to the power minus 2 mole dm minus 3, right? Then pH will be 2, right? Simply what you have to do, you have to take this 10 to the power minus this 2 and plus 2 you have to put, right? This minus 2 will be becoming plus 2. If the concentration is 1 into 10 to the power minus 3, then pH will be 3. If the concentration is 1 into 10 to the power minus 7, the pH will be 7, right? So like that you can put. Now if there's a different value, like for example if you take concentration is like assume like concentration is 2.1 into 10 to the power minus 2, right? First of all you had to write it in the right. Let's assume that the concentration is 21 into 10 to the power minus 3, right? Then first of all what you have to do, you have to write this in the scientific notation. What is the scientific notation? 2.1 into 10 to the power minus 2. Then what you have to do is to find the pH, right? From 2, right? This 10 to the power minus 2, right? From take that 2 front, and from that 2 you have to reduce log value of 2.1, right? Then you will get the pH value, right? If they have given some value like, let's take as another example like another value 4.3 into 10 to the power minus 5, right? They have given this, how to find the pH? PH will be equal to 5 minus log value of 4.3, right? Log value of 4.3, like that you can find the pH, right? Just if the concentration is like 1 into 10 to the power minus 8, then the pH we can directly write it as 8, right? 8. Okay, that's how you have to find the pH values. Okay, so you have to write the concentration of H3O plus in scientific notation, scientific form, and then you have to do the calculation, right? So initial pH inside the titration flask is uh, 1, right? So what are they asking next? Calculate the pH of the solution in the titration flask after the addition of 10 centimeter cube of the solution of B. Right now, what are they doing? They're adding 10 centimeter cube of B. Right? They're adding 10 centimeter cube of B. Right. So from here, they're adding 10 centimeter cube of B. Now, what will happen if you add the base to the acid? It will react. Right? It will start to react because acid and base will be reacting. Right? So the moment you add the weak base, it will start to react. Then what is the reaction? B will be no. B will be reacting with HCl, right? And will be forming BH plus, right? BH plus and Cl minus will be formed, but Cl minus is not necessary in our calculations because it is a spectating ion, right? It is a spectating ion, therefore Cl minus is not necessary in our calculations, right? So how can you write this equation? Now you know B is a base, right? So what do bases do? They will release either OH minus or they can accept H plus ions, right? So for example, if a compound can accept H plus ions, then we say it is a base, right? Or if a compound can release OH minus, then we can say it is a base, right? So here what is happening is the compound is accepting H plus ions, right? And the donator of H plus ion is the acid, right? That is HCl. So HCl donates the H plus and base will be accepting the H plus ion. So this is the reaction, right? Now what will happen? You're adding B, then B will start to react with HCl, right? So what is the amount of B added to the solution? What is the initial amount of B? Initial, I'll take this initial moles. What is the initial moles of B? right? The concentration have been given 1.5 into 10 to the power minus 1, right? And the volume they have given as 10 centimeter cube. To convert into decimeter cube, I'll divide by 1000, right? I'll be dividing by 1000, right? What is the concentration, sorry, moles of HCl? uh, what is the moles of HCl initially? Concentration have been given, so this is HCl, right? 1 into 10 to the power minus 1 is the concentration. The volume present in the titration flask is 25 centimeter cube, right? So volume is 25. To convert into decimeter cube, I'll be dividing by 1000. Now what is the initial moles of BH plus? That is 0. That is 0, right? Now what will happen? They both will be reacting, right? So what is, how to find the reacted moles? You have to consider the limiting reagent, right? So who is the limiting reagent out of these two? B is the limiting reagent, right? So B will be reacting completely. So 1.5 into 10 to the power minus 1 into 10 over 1000. That is the reacted moles of B. So how much will of HCl will react? Ratio is 1 is to 1. So same amount of HCl will be reacting, right? So 1.5 into 10 to the power minus 1 into 10 over 1000. Then how much of BH plus will be forming? How much of BH plus will be forming? So I'll write it like this. Same amount of BH plus will be forming. What is the reason? Ratio is 1 is to 1 is to 1, right? So same amount of BH plus will be forming. That is 1.5 into 10 to the power minus 1 into 10 over 1000, right? So no need to consider about Cl minus ions, because that is a that is a spectating ion, so it does not affect the pH, right? So no need to find those, right? Okay. Now what is the final moles? This is the reacted moles. So what is the final moles? How can you find the final moles? Final. So final moles, right? FM I'll put. So you have to reduce the reacted moles from the initial moles. So here if you reduce it, it will be 0. Here if you reduce it, 10 to the minus 1, then 25, right? 1 into 10 to the power minus 1 into 10 over 1000 will have, right? And this is the same value because initially BH plus is not there. This amount was formed. So finally you have this same amount, 1.5 into 10 to the power minus 1 into 10 over 1000, right? Now, okay, this is after the reaction. This is the final moles present in the titration flask, right? Now, who's going to decide the pH of the solution in the titration flask? Who's going to determine? Because HCl is there, it's just acid, so it can determine the pH. Also, BH plus is also a weak acid, right? Why? Because BH plus can donate H plus to the solution, right? See, BH plus when put it in the solution, it will be partially ionizing because this is a weak acid. So it will form BnH3O plus, right? So you can see that BH plus BH plus can release H3O plus to the solution. So this also can affect the pH of the solution, right? Now who's going to determine the pH? Is it HCl or BH plus? Now you see BH plus is a weak acid, right? So normally BH plus will provide little amount of H plus normally, right? If you take normal. Now HCl is also present in the solution, right? So definitely HCl is going to ionize completely because it is a strong acid. So definitely HCl will be ionizing completely and providing H3O plus ions to the solution, right? Now what will happen? The concentration of H3O plus will be higher. The concentration of H3O plus will be higher. What is the reason? Due to ionizing of HCl acid, the concentration of H3O plus in the solution will be higher, right? So if the concentration of H3O plus will be higher, according to Le Chatelier's principle, in this reaction, the backward reaction will be favored, right? The backward reaction will be favored, right? So the ionizing of BH plus will be more lesser, right? Because H3O plus common ion is present. Due to the ionizing of HCl, there will be more H3O plus in the solution, right? So if more H3O plus is present in the solution, then according to Le Chatelier's principle, the backward reaction will be favored, resulting in lesser ionization of BH plus ion, right? So the pH will be mainly determined by HCl because the ionization of uh, BH plus is very negligible amount, right? Compared to the H3O plus provided by HCl, the H3O plus provided by BH plus is very negligible amount, right? So therefore, the pH is determined here only by HCl, right? So you have to get that idea, right? Now, HCl is going to determine the pH. So we had to find the concentration of H3O plus ions, right? So concentration of H3O plus ions will be equal to the concentration of HCl, right? So what is the concentration of HCl? This is the final moles of HCl, right? The moles I have 1 into 10 to the power minus 1 into 10, right? I can put 1. 1 10 to the power minus 1 into 10, I can put 1, right? So 1 over 1000, this is the moles. So I'll write it as this way, right? This is the moles of HCl, right? 1 into 10 to the power minus 1 into 10 over 1000. This is the moles of HCl. So how can you find the concentration? You have to divide by the volume. So what is the volume of the solution now? Is it 25? Come on, is it 25 centimeter cube? What is the volume of the HCl solution? Is it 25? Volume of the solution? No, it's 35, right? What is the reason? You're adding 10 centimeter cube of base, and initially there was 25 centimeter cube HCl. Now the total volume of the solution has become 35 centimeter cube. That is 25 centimeter cube plus 10 centimeter cube. That is the total volume of the solution, right? Now after addition of weak base, if you consider the HCl solution, the volume will be 35 centimeter cubes, right? So you have to divide this by 35 centimeter cube. You have to be very careful with that, right? So the volume is 35 centimeter cube, right? And I have to convert it into decimeter cube, so I have to multiply by 1000, right? Now I can cut this 1000 and this 1000. So 1 over 35, that is, what is 1 over 35? Let me use the calculator. That is 0.028, right? I can write it as 2.8 into 10 to the power minus 2, right? I'll write it as 2.8 into 10 to the power minus 2 mole dm minus 3. That is the concentration of HCl, and also that is the concentration of H3O plus, right? Because here we are assuming H3O plus obtained from HCl only, right? Because BH plus does not ionize, right? The amount that is ionized from BH plus, we are assuming it as negligible, right? As explained before. Right, now how can you find the pH? pH is equal to negative log 10 concentration of H3O plus aqueous, right? You all have to write this equation in the exam, because for this they are giving marks also, right? So next for the substitution will be getting marks, that is negative log 10. What is the concentration of H3O plus? 2.8 into 10 to the power minus 2, right? Now how can you find the value? From 2, you have to reduce the log value of 2.8, right? Log 2.8. What is the log value of 2.8? 4472, right? That is 4472. 2 minus 0.4472, right? Then the value answer will be 1.56, right? So approximately you can take as 1.6. Okay, so the answer will be 1.56. That is the pH of the solution after addition of 10 centimeter cube of the weak base, right? Did you all get it? Did you all get it? Okay, right? Okay. Why is the volume 35 centimeter cube? Right. You see now, if you consider the HCl solution, initially it was in 25 centimeter cube. Assume that you are the HCl, right? You were in 25 centimeter cube initial, right? After that, weak base was added, right? After weak base was added, now the HCl is present inside 35 centimeter cube, right? It is present inside 35 centimeter cube. So the volume the solution is present is 35 centimeter cube, right? So when finding the concentration, you have to divide by 35, not 25, right? 35. So I hope you got it right. Okay, right. 1.56, 1.62, right? Okay. Now pH, I'll note that down also. pH after addition of 10 centimeter cube, right? That is 1.6. I'll take it. 1.6, right? pH initial, right? Was 1. Okay. Now what is the third question they're asking? Okay, they are asking that the same question. There is another part. Calculate the pH of the solution of the titration flask after addition of 10 centimeter cube of the solution B, right? That we found. That is 1.6. Next, they are asking, can the solution in the titration flask act as a buffer solution? They are asking whether the solution can act as a buffer solution, right? At the end of the reaction, there is solution, right? So, can that act as a buffer solution? Is the question they are asking, right? Now, what is a buffer solution? Right, so for solution, if you add small amount of acid, or if you add small amount of base, or if you add water, right, if you dilute the solution, if the pH of that solution change is very negligible, right, if there is no change in pH, or if the pH change is very small amount, then we can say that type of a solution as buffer solution. What is a buffer solution? Upon addition of base, or upon addition of small amount of base, right? Or upon addition of small amount of acid, or upon dilution, if the change in pH is very negligible, right? If the change in pH is negligible, then that type of solution we say it as buffer solution, right? So normally, what are buffer solution? Right now, the definition of buffer solution is okay. Now, which solutions can you consider as buffer solutions? If a solution has a weak acid and its conjugate base, yeah, then it is a buffer solution, right? Or if a solution has weak base and its conjugate acid, then it's a buffer solution, right? So for a solution to become a buffer solution, it must have the weak base and its conjugate acid, or it must have the weak acid and its conjugate base, right? Now here weak base only we are adding, right? So for solution to become buffer solution, at the end of the reaction, it must have the weak base and its conjugate acid, right? So if you take here, the weak base concentration is 0. So there is no weak base. But conjugate acid is present, right? So for solution to be buffer solution, it must have both weak base and its conjugate acid, right? So here weak base is not present. Therefore, this solution is not a buffer solution. Okay, so this solution is not a buffer solution. Reason is weak base is not present, right? Weak base concentration is very 0, but conjugate acid is present. But for solution to become a buffer solution, both must be present, right? So this is not a buffer solution. Okay, right? Okay. Next, what are they asking? Calculate the volume of the weak base solution required to reach the equivalence point. They are asking the volume of the weak base, right? Required to reach the equivalence point, right? Asking the equivalence point, the volume of the weak base, right? What is equivalence point? What do you mean by equivalence point? Equivalence point, right? Equivalence point is the exact amount of titrant. We normally call this the titrant and we call this the analyte, right? The solution in the titration flask is the analyte. The solution in the burette is the titrant, right? So the exact amount, right, volume of titrant needed to react with the analyte, needed to react completely with the analyte, right? So that is what is called as a equivalence point. So at equivalence point, we can say here in this case, at equivalence point, moles of HCl will be equal to moles of weak base, right? Because ratio is 1:1, right? So if what is the moles of HCl now? NHCl. That is the moles of HCl. What is the moles of HCl? 1 into 10 to the power minus 1 thousand into 25, right? So that is the moles of HCl, right? So what is the moles of B needed to react completely with HCl? What is the moles of base needed to react completely with HCl? The same moles is needed, right? Because the ratio is 1:1. So moles of base needed to react completely with HCl will be equal to this value, right? That is 1 into 10 to the power minus 1 into 25, right, over 1000. In bracket, if right possible, B is to HCl ratio is 1:1. Therefore, the amount of base needed to react with HCl is same amount, right? Now we know the moles of base needed, so we have to find the volume needed, right? So how can you find the volume? You can use the equation N equals CV, right? What is N? Moles of base. What is the moles of base? 1 into 10 to the power minus 1 into 25 over 1000. That is the moles of base needed, right? And what is the concentration of the base added? 1.5 into 10 to the power minus 1. That is a concentration. 1.5 into 10 to the power minus 1 is the concentration, right? To find the moles, then you have to multiply by the volume. So this volume, if you put in decimeter cube, then this is correct, right? But final volume we have to get in centimeter cube. Normally we provide the final volume in centimeter cube, right? So to convert this, to obtain the final value as centimeter cube, what I can do is I can divide by 1000, right? Now if you get the value of V, that will, you will get in centimeter cube, right? The volume, the unit will be in centimeter cube. So that's easy, right? Now 1000 you can cut, 10 you can cut, 25 divided by 1.5. So volume is equal to 25 divided by 1.5, right? So I'll check with the calculator and tell you. 25 divided by 1.5, 16.66 I'm getting, right? So I can write approximately 16.7 centimeter cube, right? Right, okay. Now what is equivalence point? Equivalence point is the exact volume of titrant needed to react completely with the analyte. That is the equivalence point, right? So you have to find the moles of B needed. First of all, you have to find the moles of B. Then only you can find the volume of B needed, right? So moles of B needed to react exactly with HCl is same amount as that of HCl, right? The reason is 1:1 ratio. So you need this amount of moles of B base to react completely with HCl, right? So here we are putting the moles of B, we are putting the concentration of B, and we are finding the volume of B needed, right? That is 16.7 centimeter cube, right? I hope you all understood. Now let me ask you a question, right? What is the difference between equivalence point and end point? What is the difference? Anyone? Okay, right. Let me tell you. Now, equivalence point is the theoretical point that you can obtain, right? Like the calculated point is the equivalence point, but actually in practical world you can't obtain this exact value, right? Because we are, how can you find the equivalence point? You have to find the volume, but we are finding the endpoint is found when there is a change in the color of the indicator. We normally put an indicator for these titrations, right? So you will be adding weak base to the titration flask. So the moment the color changes in the titration flask, we say that volume of base added is the endpoint, right? So normally endpoint is the practical value of equivalence point, right? Because human has errors, right? So he can't find this exact point, right? So endpoint will be a slightly higher value than this equivalence point, right? So that's the endpoint. Endpoint is the practical value, this is the theoretical value. Equivalence point is the theoretical value, endpoint is the practical value, right? Okay, that is not needed much, but you have to remember that endpoint is always greater than equivalence point. You have to remember that, okay? Endpoint is always greater than equivalence point. So I'll write the equivalence point. V equivalent 16.7 centimeter cube, right? 16.7 centimeter cube. Okay, then what are they asking? Next part. Another 10 centimeter cube volume of the weak base was added to the titration flask after reaching the equivalence point. Calculate the pH. Now what are they doing? They are adding another 10 centimeter cube after equivalent point is reached, right? Now equivalence point is 16.7, right? Now they are adding another 10 centimeter cube, it seems, right? Another 10 centimeter cube is added after adding equivalence point value, that is 6.7 centimeter cube, right? So what is the total value that is added? Total value of base that is added, 26.7 centimeter cube is added to the solution, right? Right now they're adding 26.7 centimeter cube, right? Now you have to think from the first, right? You have to reset it, right? Now before the addition of base, right? Now assume, you have to assume that 26.7 centimeter cube is added to the titration flask, right? From that only you can do the calculation. Okay, now what is going to happen? B is going to react with HCl, right? B is going to react with HCl and will produce BH plus, right? I'll ignore the chloride ions. So B is going to react with HCl and produce BH plus, right? Now what is the initial moles of B? I'll write it as IM, initial moles. Initial moles of B. Initial moles means after addition of 26 centimeter cube into the titration flask, what is the B that is present, right? Before the reaction, what is the B present? 1.5 into 10 to the power minus 1 present in 1000, 26.7. That is the initial added moles of B, right? What is the initial added moles of HCl? That is the moles present in titration flask. That is 1 into 10 to the power minus 1 into 25 over 1000. So initially BH plus is not present, right? Now what is going to happen? Reaction is going to happen. So you have to find the reacted moles, right? So how can you find the reacted moles? You have to find the limiting reagent, right? Now who's the limiting reagent? HCl is the limiting reagent, right? So HCl is going to react completely, right? So yeah, HCl is the limiting reagent. HCl is going to react completely, right? As the ratio is 1 is to 1 between the acid and the base, same amount of base is going to react, right? That is 1 into 10 to the power minus 1 into 25 over 1000. So same amount of BH plus is gonna form. What is the reason? 1 is to 1 ratio. So the amount of BH plus formed is 1 into 10 to the power minus 1 into 25 over 1000. Over 1000. Now what is the final moles present? Final moles. So you have to reduce the reactor moles from the initial moles, right? So if you reduce, you'll have, right. I'll use the calculator. If I use the calculator, 26.7 into 1.5. 40.05, right? 40.05 minus 25 is gonna be 40.05. If I is 15, right? 15.05 into 10 to the power minus 1 over 1000, right? Okay. Now what is the final moles of HCl present? That is 0, right? What is the final moles of BHS present? That is same amount, right? 1 is to 10 to the power minus 1 into 25 over 1000. Now who's going to determine the pH? Now HCl is not present in the solution, right? So weak base and its conjugate acid is going to determine the pH of the solution, right? So we have to write the Kb expression. I heard we have to find the, now if you take B will be present in the solution and also BH plus will be present in the solution, right? Now this is a weak base, right? So it will be ionizing partially. So what is the ionizing reaction? B is gonna react with the water present in the solution and is gonna ionize partially, right? It is gonna ionize as BH plus and OH minus, right? So it's going to ionize as follows. So I'll keep some space and I'll write. Okay, right? Now, what is the initial moles of BH plus present? Uh, I'll write the initial concentration, right? I'll write the initial concentration. IC, initial concentration. This is the final moles, right? Final moles is what? 15.05 into 10 to the power minus 1 over 1000. This is the final moles of B. How to find the concentration of B? I have to divide by volume. What is the volume now? 25 was present initially and you added 26.7 centimeter cube weak base, right? Now the solution volume is 26.7 plus 25, that is 51.7, right? 51.7, and to convert into decimeter cube I am multiplying by 1000, right? I hope you understood, right? 15.05 into 10 to the power 1 over 1000 is the moles, right? To find the concentration, I have divided by the total volume of the solution, right? The total volume is 25 plus 26.7 because you're adding 26.7, 25 to the 25 centimeter cube solution. So the final volume is 51.7, and that is in centimeter cube. To convert into decimeter cube, I multiplied by 1000, right? That is the initial concentration of B, right? What I now need to know. So BH plus, what is the initial concentration? This is the moles, right? This is the moles. To find the concentration, I have to divide by the volume. Now BH plus is also present in this solution, right? In this titration flask is also in this titration flask only BH plus is also present, right? So what is the volume of the solution? It is present, same volume, that is 51.7, right? Because BH plus B, everyone are present in this titration flask, right? So right, so everyone is present in this titration flask, so everyone will be having the same volume of the solution, right? So that is 51.7, and to convert into decimeter cube by multiplying by 1000, right? So initially there is no OH minus, right? Initially there is no, then there will be some reacting reacted concentration will be there. Let's assume that X amount reacted and here X amount formed, and let's assume that here also X amount formed, right? Because 1 is to 1 ratio, right? If X reacted, X will be forming and X will be forming. Now what is the final concentration? So you have to reduce the initial reacted concentration from the initial concentration, right? That is 15.05 into 10 to the power minus 1. I can cut this 1000 and 1000. 10 to the power minus 1 over 51.7 minus x, right? So here also you have to add that value, right? So I can cut this 1000 and 1000. So 25 into 10 to the power minus 1 divided by 51.7 plus 6, right? Divided by plus 6. So what is the final concentration of OH minus? That is X, right? So now what you have to do, using these values, you have to substitute in the Kb expression, and you can find the concentration of OH minus, right? Let me erase this. So I'll erase this, right? So I have to write the Kb value. What is the Kb value? First I have to write the Kb expression, right? So definitely don't forget to put the physical states, right? You have to put aqueous, liquid, aqueous, because physical states is very compulsory. You have to put physical states, right? Because marks is allocated for physical states also. But what you have to, how to write the Kb expression? BH plus aqueous into OH minus aqueous divided by B aqueous, right? Divided by B aqueous. Now Kb value they have given, right? Before writing that, what is the concentration of BH plus? This is the what is the concentration of BH plus? This is the concentration of BH plus, right? But we are making assumption here. What is the assumption? 25 into 10 to the power minus 1 over 51.7, right? This value plus x, right? This is the concentration of BH plus, right? So what is the assumption we are making is this is approximately equal to 25 into 10 to the power minus 1 over 51.7. This is our assumption, right? Because this x amount is breaking and x amount is forming, right? Compared to this value, right? Compared to this value, this x amount that is formed is very small amount, right? For example, this x might be in 10 to the power minus 7 minus 8 values, it can take, right? So that is like 0.000008 is 001, right? 36 another 0 also, right? Something like this, right? So no point of adding this value to this value, right? So it will be approximately equal to this value, right? So this is correct, right? This assumption is correct because x value is a very small value. So you can take this assumption, right? Same way for this also you can take that assumption, that is 15.05 into 10 to the power minus 1 divided by 51.7 minus x is approximately equal to 15.05 into 10 to the power minus 1 divided by 51.7, right? It's like something, yeah. For example, let's take from 500,000, you're adding like 1 rupees, right? From 500,000 you're adding like 0.1, right? That is equal to how much? 500.01, right? That is approximately equal to 500,000. Something like this only here is also happening, right? Here this is a larger value compared to this x value, right? So we can assume this as this value, right? Something like the same scenario. Okay, right? So we are making this assumption and we are substituting these values into this expression, right? That is what we are doing. So you have to write this assumption and you have to substitute that value to the equation. So BH plus you can take it as 25 into 10 to the power minus 1, right, divided by 51.7, right, multiplied by concentration of OH minus we don't know, that is X, right. So we are writing that amount and divided by this value concentration of B, that is 15.05 into 10 to the power minus 1 divided by 51.7, right. Now I can cut this 51.17, right. So 10 to the power minus 1 also I can cut. So 25 divided by 15.05, right. Now I can find the concentration of OH minus, right. So Kb value also they have given, right. Kb value is 1 into 10 to the power minus 5, right. So Kb is also given. So from that, don't forget to put the units also, right. So 1 into 10 to the power minus 5. So the concentration of OH minus I can find from this, that is, so let me use the calculator. 15.05. I'm getting 0.602, right. So I can write it as 6.02 into 10 to the power minus 6 mole dm minus 3. That is the concentration, right. Now if I know the concentration of OH minus, I can find POH, right. So what is the equation of POH? POH is equal to negative log 10 concentration of OH minus aqueous, right. Same way as the pH equation, right. So only these two changes, pH becomes POH and H3O plus becomes OH minus, right. So you can put this value negative log 10 6.02 into 10 to the power minus 6, right. So how can I find the value? So from 6 I had to deduct log 6.02, right. Log 6.02 is log 6.02 is 7796, 7796, right. That is 6.6 minus 0.7796, right. So what is the answer? What is POH? 6 minus zero point 0.7 is I can take 5.3, approximately 5.3, right. It will become 5.23, it will be like 5.23, right. This is the value, right. Now how can I find the pH? So we know that pKw is equal to pH plus P POH, right. So pH, you can find this equation, pH is equal to pKw minus POH, right. That is pKw is 14 and POH is we found that 5.23. So what is the pH value? 8.77, right. 8.77, 8 point, yeah, 8.77 is the pH value. Did you all get that? Right. 8.77, you can write 8.7 or 8.8. So approximate values, for that they will give marks, right. I hope you all got that, right. And what are they asking next? So when substituting for the Kb values, definitely put the unit of Kb, unit of BH plus, that is mole dm minus 3. You have to put here also mole dm minus 3, right. So units are very important and also physical states are also important, right. And they're asking, can the solution obtained in 4 above act as a buffer solution? Can this act as a buffer solution? So you can see after addition of 26 centimeter, 26.7 centimeter cube of weak base, it reacted, right. It started to react and the HCl became the limiting reagent. And the final mole of HCl was 0, right. Then when you check it, you had weak, some of the weak base remaining. Also there was BH plus also, right? Both BH plus and B both were there in the solution after adding 26.7 centimeter cube of weak base, right? So here you can see you had the weak base also and you had the conjugate acid also, both are present, right? If weak base and conjugate acid present, then we can say that solution as a buffer solution, right? So this solution can act as a buffer solution. Reason is both weak base and conjugate acid are present, so this solution, right, after the titration, that solution can be used as a buffer solution, right? And final one, they're asking is get the variation in pH of the mixture in the titration flask with the volume of the weak base, right? They're asking to sketch the pH, right? So I'll note this down also. pH after addition of 26.7. That is 8.77, right? The pH was 8.77. Okay. Now they're asking to sketch the pH curve, right? They're asking to sketch the pH curve, right? Sketch the variation in the pH mixture, right? So y-axis is the pH and x-axis is the volume of the base, right? Volume of base, that is also a centimeter cube, right? You have to put the units also in the respective axis, okay? Label axis indicate pH on the y-axis and the volume of the weak base on the x-axis. Mark the equivalence point approximately, right? Calculation of pH at equivalence point is not expected, right? So that is not expected. Right, okay. So pH curve. What is the initial pH before the addition of weak base? The initial pH was 1, right? So the curve must start at 1, right? And the equivalence point is 16.7 centimeter. Okay. Now, what is the pH? Right? They have said no need to calculate the pH at the equivalence point, but you can find the approximate value, right? Mark the equivalence point approximately, right? They are asking the approximate value of equivalence point, so you can get a rough idea using the acid and base that you are adding, right? So if you titrate a strong acid on a strong base, if you titrate a strong acid on a strong base, then at equivalence point you will have a neutral salt, right? You will have a neutral salt. What do you mean by neutral? pH is 7, right? So at equivalence point pH is 7 if you titrate a strong acid and a strong base, right? If you titrate a strong acid and a weak base, if you titrate a strong acid and a weak base, the salt will be a acidic salt, right? The salt will be acidic salt because the acid is strong, right? So the salt formed will be strong, right? So if the salt is acidic, then pH will be less than 7 at equivalence point, right? So if you titrate a weak acid and a strong base, what will happen? If you titrate a weak acid and a strong base, the salt will formed will be a basic salt, right? If the salt is basic, the pH at equivalence point will be greater than 7. And if you titrate a weak acid and a weak base, you can't tell the nature about the salt because you need the Ka and Kb values, right? So you can't tell the nature of the salt, but out of these three, you can tell the nature of the salt, right? So now here we are titrating a weak base with a strong acid, right? Weak base with a strong acid, then the salt formed at the equivalence point will be acidic salt, which means the pH will be less than 7 at the equivalence point, right? So pH must be less than 7 at the equivalence point. So you have to show 7 somewhere here, maybe somewhere around here, right? Show somewhere here. So the curve must start at 1. So something like this you should have, right? So the steep pH change. This is the steep pH change, right? So the steep pH change is the equivalence point, right? The steep pH there is a change, right? That is the equivalence point. The volume of equivalence point is 16.7 centimeter cube, right? You have to mention that also. And pH at this point is not needed, but you have to write this, okay? You should know that the pH is definitely below 7. That you should have idea. And here it must be going closer to 9 something, right? We found after adding 10 centimeter cube, the pH was 8.77, right? After adding of 10 centimeter cube to the equivalence point, right? So somewhere close to 9, the graph should go, right? So what are they expecting? I'll tell you. Mm, below the curve must start at pH 1, right? It must reach around pH 9, right? And it must have the correct shape, okay? And the equivalence pH, right? That is the steep pH must be between pH 5 and 7. That must be below 7, right? Mainly below 7, and it must be above 5, because pH 1 2 means it's a strong acid. So at equivalence point it is an acidic salt only, but this is not strong as this acid, right? So it must be like below 7 and above like 4, 4.5. It must be above 4, right? And the excess must be labeled with the units, right? pH must be labeled, and volume of base must be labeled with the units, okay? So that is what is expected in the graph, right? Right, that is the end of the question. So they have not asked one part of the question, but still I'll explain that, okay? Because most of the time they ask that. That is, at the equivalence point, who will determine the pH of the solution, right? If you take here, base is added and HCl will be added, right? Base will be added to the HCl solution and BH plus will be formed, right? Now we'll say some amount, equal amount of HCl is present and same amount of base was added, right? And they'll be reacting and finally there'll be zero, right? Zero HCl and zero base will be present, but BH plus will be formed and BH plus will be there. Let's assume you're adding X amount of HCl to X amount of, I didn't take the exact amounts, right? Just to give the idea, right? Now, let's assume that here you're having X amount of HCl, right? And you're adding X amount of base to that, and both will be reacting same way. XX amount, XX amount will be reacting. So finally, the concentration will be 0, 0, and here there will be X, right? This is the equivalence point scenario. The concentration of HCl and the concentration of B will be 0, right? So who's going to determine the pH at this equivalence point? Now HCl is not there, so he can't determine the pH, right? B is also not there. Then who's going to determine? BH plus is going to determine the pH, right? Now you can say BH plus is a weak acid. So BH plus can ionize in water, right? It can ionize and it can form BnH3O plus, right? So this formed H3O plus can determine the pH, right? So to find the exact H3O plus, you need the Ka values, right? You need the Ka values. Those are not given in this question, and this not has been asked also, right? So they are not expecting the pH at the equivalence point, but pH at equivalence point it is determined by BH plus, right? So you should have that idea, because commonly in titration they will ask that also, right? Uh, so that's it, right? There is no any other doubts, right? Okay, right. Okay, then we'll meet in the next question. Okay, have a nice day.